Welcome, guys, and I appreciate the opportunity to meet with you all today. I will warn you, I definitely have much more content that my 25-minute allows, but that's okay. I wanted to give you more information. This will be presented and available to you so you guys can refer to it later. There is a couple slides in here that in all my talks that I give, there's always a few takeaway slides. It's like, this is the one you're going to remember this slide, and I'll spend a little bit more time on those. Those are the takeaway slides. What we're going to hit in this session today is how do we actually start thinking about the next evolution of putting an agentic AI capability on the factory floor. And what we're also going to do, there's really two parts in our discussion today. I'll tell you a little bit about the benefits. We'll talk about why we want to consider doing that. But the very first thing I'm going to really get into is I feel like many times we're using these words very loosely. What does agentic AI truly mean? I built my first AI engine in 1992. I've seen this evolution. So when we say AI, to me, it's like, well, it's not ChatGPT. You know, there's many, many different flavors of AI. And so we've been using in manufacturing AI ever since I was involved in 92. We've had all different types of systems. So we're going to re-educate. We're going to talk a little bit from my perspective, what does agentic mean? And then we're going to talk about a really powerful capability, what we call tools. And we'll compare and contrast that of RAG, or retrieval augmented generation. Now, I will go a little bit into the bits and bytes in here because I think it's important that we have, and don't worry, it's not really that deep, but it's enough that I want to give everybody a good grounding. So one of the things I'm not going to go into, let me just kind of set the stage. Let me just show of hands, how many people have a familiarity with RAG, retrieval augmented generation? Okay, all right, so we got a mix in here. And I'll talk a little bit about that, but we are going to do a little comparison and contrasting here. And then that's the first part, really kind of ground us. The second part, I'm going to show you how we've taken an existing AI system where we're doing predictive maintenance. We've been doing predictive maintenance with models on the factory floor for a couple decades now, and we're really, really good at doing that. But now, how do I take a system like that and upgrade it or make it to become agentic? And what does that really mean? And that's what we're going to go through. And some of these slides, I will go fast through it. It's for your reference, but I'm just going to go through because I want to get to the kind of the good stuff, if you will. So let's talk about the drivers. Why are we even considering putting agentic capabilities on the factory floor? What's driving us? Well, let's think about what we do today. I already shared, and those who worked with manufacturers, you know, we've had it on the floor for many years. We've done computer vision. We've had computer vision doing quality inspections for over 2 decades now. Predictive maintenance, we've been doing that for nearly 30 years of when a machine potentially could fail or how much remaining useful life is left in that. And then anomaly detect, that we in our last session, we heard at the panel, we heard the team talking about building anomaly detect models when there's variations off of the norm. So that's what we're doing that today. But what's falling short? Almost every one of those systems that I outlined, they notify you of a potential problem, or they notify you of a problem. Even if you're using generative AI will still say, hey, I think this is going to fail. It'll send you a note to the technician on the floor. You really should think about doing something about this. And that's it. If that's ignored, the machine still fails. Now, you may remember, the reason we're putting all this AI onto the factory floor is predominantly to do one thing: reduced unplanned downtime. Unplanned downtime costs us globally right now about $3 trillion a year of machines simply not running because they break when we didn't expect them to. That's very material. So our objective here is how can we reduce unplanned downtime, duration, and the frequency of it. Our data sets are very siloed. And guys, in any AI conference or data conference, we're always going to talk about the data. It was said multiple times, you don't get that right, you're going to have a problem. Remember, models, they have no idea of right or wrong. They don't know what's truth or not. They don't know anything. They have no context of that. And now we compound it by all the data sets that we're using are all siloed. And then the last part of this is there's really no autonomous executions. I already kind of went over that to a degree of when I get notified there's a problem, AI is predicting something's going to fail. It's still up to me as the human to do something about it. And then there's many different pain points. You can see those that we have up there. So let's go into my wife always likes to joke, by the way, if I wasn't doing this, I would actually just be a college professor. So I apologize for my style. It's the way I am. I get excited about this. I always feel like I'm teaching. So I'm going to do a little bit of teaching. So forgive me for those who are experts in this area, and it's redundant, but I enjoy this part of it. Agentic is a very powerful concept. It now starts to introduce the ability to understand, reason, and plan. And that planning piece, to me, is so amazing. Even though I've been doing AI now for over 35 plus years, and I'll tell you some stories when we get to this planning phase. So we now have systems in our agentic platforms that we build today that our clients discover things that it's doing autonomously. We see emergent properties, things we did not explicitly program it to do, and it did. I was with a client last week and they told me, hey, Guy, I was running the system, the knowledge graph knew all the different changes throughout the system, and it automatically said, hey, you need to rerun all of these tests because there was a change. We did not tell it to do that. So that's like, wow, the sequencing, this planning that an LLM can bring in is unbelievable. The next big part is because sequencing is not always programmed. It's coming as a property of the LLM. So now I can decide what to do. Now I'm starting introducing the agent, the agentic piece. What actions am I going to take? And then, and this is where it starts to get a little scary, it acts. And it does it without the human intervention. Now, today, and I'll talk about this at the end a bit more, but we always talk about, you may have heard the term, we talk about human in the loop. Most of the systems today, we keep the human in the loop. Yes, we have our guardrails to keep things intact, but really to keep things in order, we have humans in the loop. With agentic systems, this changes. We're now moving to what we call humans on the loop. The human sitting on top of this and looking and orchestrating as more an advisor of the system. This is a big, big change, particularly in manufacturing. And so now we're starting to hand over some of the controls of the systems in these factories. Now, these systems, and we're going to reemphasize this again in a little bit in a few minutes, learning and improving. To be truly an agentic system, it must be a closed loop system. And what we close the loop on is, did I make the right decision? Because remember, we're going to a world in manufacturing, and most AI systems up until this point, and most software systems used in manufacturing are very deterministic. I follow a very clear set of rules. I can tell you what's going to happen. You give me a temperature, I'll respond this way. You give me an oil pressure, I will do this. It's very fact-based rules. That is a form of AI, rules-based engines. But now, when I introduce the concept of an LLM with agents or making an agentic approach, I'm now going to something that has a probabilistic nature. Not quite non-deterministic, definitely probabilistic. And we don't like that in manufacturing. We like a binary. We like it's either right or wrong. We don't like the gray zone. Now, this goes beyond factories, by the way, what I'm saying. For any enterprise workflow introducing us, particularly your regulated industries, this is the unnerving part. And if you think about it for a moment, it really shouldn't be unnerving. Do you know why it shouldn't be? The agentic system is what I call a human emulator. The irony of all this, we're all scared of AI, of what it's doing. It's doing nothing but emulating what we do. Even when we put a human in the loop, we're non-deterministic. We still give a probabilistic. I could give you guys a case study, a set of diagnose the problem, what we should do about it, and I'm going to get 50 different answers. Oh, sounds like AI. So it's emulating us. But we were used to the technology on the floor not being like us. We were used to it being very exacting in what it did. And we're changing that. So it's imperative we learn and improve, just like a human. That's what we mean by closed loop. And we're gonna deep dive into that. So to be truly agentic, if you don't fulfill a closed loop system like this, it's not agentic. So our business case is very compelling. Why do we want to do this? When we look at it, and guys, we have a ton of data. I can give you some productivity numbers, but we see very material impacts. I like to tell people agentic AI systems are a force multiplier. It really is creating a suite of superhumans. I also like to talk about the business case for this, and I guide my clients all the time in this when we work with them. Don't look for the cost savings using these methods. What you really want to look for is time compression. That is the key. It's not about the cost savings. Cost savings emerge because you're doing things faster. But if you really want to make an improvement in a factory setting, I would even argue in most enterprise, it's to reduce the time to take action or decide or to get a result. It's about time compression. So when we look at all these different types of items around the business case, it really is about focusing on how do I reduce time. I like to tell my clients, if you get this right, and this is more on our software development side of our business, like now we get productivity gains with our we use an agentic approaches to doing software development now, where we can see productivity gains of 3x to 4x. Unbelievable. But now clients are like, yeah, but what if you're wrong? It's like, I'll do it over. I'll still get it done in half the time. Well, if you get it wrong a second time, I'll do it over a third time. I'll still beat the traditional ways. It's about time compression. So that's what we want to think about through this. So there's benefits we gain today when we start putting these types of systems in. We do get the higher throughput. Remember, in the factory world, I'm usually only worried about two things. Am I getting more widgets out per hour, or am I saving money in my OpEx? We absolutely will get that. But what we get tomorrow is really, it's the self-optimization. It's more of the autonomous operations. So I always like to measure how many operators per machines that we're running. When we take an agentic approach to this, that ratio radically improves. We have many more machines being supported by a person. And we also start getting into the realm of self-healing. So now I'm going to go into a little bit into the weeds, the next two slides. And these are the two slides I want you to take away. Now, you guys are going to get all of these. And I know it's a bit of a technical mumbo jumbo in here, but it's really important to understand. Let me back up one. There's a takeaway down here at the bottom. Single action versus continuous action. So when we think about tools, what tools are, these are used by the agents to take a single action. So you don't have to be a software person to understand these descriptions. create work order. That's a tool. It will just go create a work order. That is not new. We've been doing that in software forever. What was new is how we start to use this in place of RAG. Now, I'm not saying RAG goes away. RAG has a very, very powerful position to be in, but RAG works best when my data is more static. Like if I want to learn on things that doesn't change very often, company policies, procedures, those don't change very often. But you're not going to build a RAG system on time series data screaming out of a sensor. It's too fast. But if I may want to query that, how do I do that? I can do it with tools. So the tools are used by the agent to create a set of one single actions. It's also, we heard in the previous talk, we were talking about guardrails. Guardrails, there's many ways of implementing, but tools are a very useful way of doing guardrails because it gets a very well-defined parameter sent to it, and it does one and only one thing, and then it's done. It keeps a lot of control on the floor, but it also allows you to get stuff in near real time. So it's much, much faster than RAG. RAG has a great place, but on the factory floor, we look at doing things for speed and a single shot with control. Tools are how we do that. Tools are invoked by the LLMs. So there's a whole other thing with skills. We tell it what skills it has. It knows how to do this. What's beautiful about it is once you write the tool, it's available and anybody now can use it, anybody being an agent in this case. So what's also one last important item. When tools are used, it's imperative because we're using LLMs. LLMs really are best at understanding natural language. And so the better you have comments literally inside the code for the tools, it makes the LLM much, much better because that's what it reads. It's how it knows when to use the tool, what the tool does, how to invoke it, what parameters. This is the most important slide. This is the actual function of how an agentic approach works. So this is written in the context of on the manufacturing line, of course. But first, we have to observe. I need the agentic system. I have to observe something happen. In this case, it's looking at a machine learning event. It could have been a sensor triggered. It came in, I detect that condition. Then reason. I have to then, the LLM gets invoked. What do I do with this sensor data? So for instance, and what we'll explore this in the next few minutes is it has to understand, like if it's a predictive maintenance failure, I'm going to fail on this date. Okay, in the old days, remember we would just notify, but now the LLM says, oh, you're going to fail. I'm going to plan something for you to solve this problem. The LLM then starts to reason. It builds the plan. We do not program it to do that. This is where it's kind of a hard thing to understand or accept as a software engineer. It will sequence the plan. Once it's ready, it will start to take action. It can invoke those tools that we saw, that we showed in that previous slide. And then once it gets done, the action's taken, it's got to reflect. It's got to learn. And so this is the other big part of it. And this is where humans come into play a lot with this. Someone's got to check. Did the action we take, was it correct? Or was it wrong? The reason that's important, think of it like it was a trouble ticket. So if that trouble ticket says the actions you took were wrong, the human would come in and enter data, you should have done this, and that gets stored. The reason that's so important, the next time the LLM goes to build a plan, it will check not only what it's been trained to do, but the memory of past actions. That's like long-term memory. So it will reflect upon that and say, oh, I wanted to do this, but last time I had this problem, there's a record that wasn't the right action. Do this instead. This is what we mean by being closed loop. And so we come back and we keep it in there. Now, this is also different than an algorithm. An algorithm will run with a finite set of steps. An agentic approach, it will run forever until the stop conditions are achieved. So those stop conditions could be, it reached its goal. What was it supposed to achieve? You gave it a set of rules, only a certain amount of iterations. Maybe there was a threshold achieved and it said, the guardrails, I'm out over my skis, call a human in to help. Stop, don't do this. Or there could have been an error. And I loved, I don't see him, but in the last session, they were talking about you just can't blindly take in that incoming data, because if you had a sensor fail and it just went flatline, you just can't have the machine react to it and think, oh my gosh, the world came to an end. Oh no, it was a failure. So you need to know the intelligence when it failed. So here, I'm going to give you 2 more slides and we're going to wrap up on here. I'm going to show you how we would apply this in a real world example. And I know there's a lot of data, and so I want you guys to have all this and you can reflect upon it, but it's consistent with some of the architectures. Eric, when you showed your architecture of the edge, the physical assets, the orchestration edge, and then the cloud. Same thing, just expanded out a little bit, right? So we got the assets down here, we got the edge and orchestration, then we have the platform, and then the analytics. What this model here is showing you, there's a machine learning algorithm that's making a prediction of an anomaly. We've done that forever, okay? Now, how do I take this, which is working, and turn it to be agentic? What do I do? So I take that machine learning algorithm piece, the analytics, and I put it into the new agentic add-on, the predictive maintenance agent in this case. Because it's now connected to all the other data sets, it can get information out of the ERP and the CMMS, and that's the tool to use to schedule maintenance. What makes this now agentic, the agent receives notice this device is going to fail on this date. I'm going to go out, use my tools, check inventory in the ERP. Oh, I do have it, or I don't have it. I need to order it. It orders it autonomously. It sees the lead time date. Then it goes and schedules it for the CMS. That is an agentic AI system. Okay. Decisions were made, a plan was created. It took autonomous actions. Now on this date, the human's got to come in to replace the machine, unless there's a humanoid robot, but let's don't go there yet. But, but now we have a closed loop system, and we can really minimize the downtime in the factories here. So architecturally, it starts to look like this. You start, and this is just a little bit more detailed version of what Eric was showing, or a slightly different version of it. But when we think about agentic systems, we are now connecting across the enterprise source of data, all the data sources. I still have an ETL layer or a data plane in here to bring the information in. We have MCP, we heard that mentioned earlier, the Model Context Protocol. And sitting on top of this are the agents running. What's really, really, really important. And the reason I showed this layer can never go past this layer. We don't want agents going right down into these source systems. Bad things can happen. So we don't want to have a wild, wild west. So having a well-defined architecture where there's protections in here will keep bad things from up here from getting down here in the bottom. So this MCP gateway is a very vital, important. We don't think of it as being a protection layer, but that's how I see it. It's really buffering the agents from doing bad things. All right. So I'm going to bring it to a close here. And like I said, there's more data that I have included in here for you guys. There's a really good case study that we've done this with. where we modified, it was a maintenance, repair, and overhaul facility where we used agentic AI and radically reduced the time it took to create quotes in their process. So they had a very material impact with that. So we outline your roadmap to follow on this. There's nothing magical about the roadmap. It's based upon the proverbial crawl, walk, run model. Start small, get value. Don't do the proof of concept. Those don't work. Do a pilot or a proof of value on a real problem. Try it and learn from that. All right. So guys, in wrapping up, what I was able to share with you today, gave you a little bit of definition of, hey, what were some of the benefits of using agentic AI in the factory floor? What does it mean to be agentic? And we talked about how agents work in a closed loop fashion and calling and invoking tools. We shared an architecture, and then we also showed how we would modify a predictive maintenance system and convert it into being agentic. Thank you. I know that was fast. There's a lot of data in here, but you have the slides and you'll be able to read it at your leisure when you're really tired at night, and it'll help you sleep. Good.